Alright, worksheet 5-2 is what we're going to start with. Just make sure my pen's working here. Alright, so first thing up here are the two definitions here. The key to verifying identities and solving equations is the ability to use fundamental identities and the rules of algebra to rewrite trig expressions. So basically what that means is, can you move things around from one side to the other? For instance, we worked on this one in class. Cosine squared plus sine squared x equals 1. We need to be able to move that around and say sine squared x equals 1 minus cosine squared x. Just as one example. Alright, so using the fundamental identities like that and the rules of algebra, minusing cosine from both sides, to rewrite them and come up with something else. Alright, and so what is an identity? We talk about the trig identities. An identity is an equation that is true for all real values in the domain of the variable. So cosine squared x plus sine squared x equals 1 is an identity because it's true everywhere on the unit circle. It's true for 0. It's true for pi over 6. It's true for everything. Say down here, 270 degrees, 3 pi over 2. No matter what you plug in for x, if you square it, cosine squared and sine squared, you get 1 no matter what. Alright, so that is an identity. Alright, so let's talk about step by step some things you can try to verify your trig identities. So first thing you're going to want to do is work one side of the equation at a time, and the rule of thumb is we're going to want to work the more complicated side first. Alright, we'll see that a lot in the 5-2 homework. Alright, look for opportunities to factor, put fractions together, so common denominators. Look for opportunities to square or create a monomial denominator. Okay, what that means is that if you have 1 over 1 minus sine in the denominator right now is not monomial, it's binomial. There's two terms, two parts to it. What we could do is we could multiply times 1 plus sine x over 1 plus sine x. And if we do that and multiply it out, we're going to end up with 1 minus sine squared x, just talking about the denominator here. All right, and that, as we should know by now, is cosine squared. So that's an example of how we would turn a binomial denominator into a single term monomial denominator. Third thing we can do is try to look for opportunities to use the fundamental identities. All right, so thinking about which functions are in the final expression. If we have a sine, we might want to use cosines. They pair up. Secants and tangents pair up. Cosecants and cotangents pair up. So what this is really saying is, back on your 5-1 worksheet, we're looking specifically a lot of the time at the Pythagorean identities. All right? So when in doubt, you can use the Pythagorean identities. I can't spell or think right now. It's the end of the day. That's not spelled right either. Identities. All right. And if that doesn't work, try converting to sines and cosines. We worked on this a little bit. If you see tan and you're not sure what to do, turn it into sine x over cosine x. All right, and lastly here, always try something. Even if it ends up not working, you're going to change things around. If you have tan, turn it into sine over cosine. See what happens. All right, so if you're stuck, just start substituting off of your formula sheet. All right, so let's try a couple examples. 3 on this worksheet. Describe a strategy and then verify that sine theta tan theta plus cosine theta equals secant theta. Our strategy here, begin by turning everything into sines and cosines. All right, always a good strategy, especially if you don't see any squares anywhere. There's no squares in this problem, so sine is already in sine and cosine. Tangent, I'm going to put a 1 under just so we can keep track of our fractions. Tangent is sine over cosine. plus cosine, put a 1 underneath there, equals secant. Secant is 1 over cosine. All right, let me clean up this part right here. That turns into sine squared theta over cosine theta plus cosine theta over 1 equals 1 over cosine theta. All right, and we need a common denominator here. We're going to times this fraction by cosine theta and see what we got now. Sine squared theta plus cosine squared theta over the common denominator of cosine theta equals 1 over cosine theta. And if we look on our formula worksheet, sine squared plus cosine squared is 1. So we have just verified the original equation is true, 1 over cosine. Let's try another. Describe a strategy here. Sine squared, cosecant x minus 1, all sorts of things going on here. The strategy, start with the more complicated side. All right, we're going to try to make the left side look like the right side. So when you have something that looks complicated, that's where you want to start. Don't start with the easy one and try to make it more complicated. All right, so the first thing, and then the other tip that we had back here, if we look at option 3, look for opportunities, number 2, look for opportunities to square, to factor. That comes into place here also. When we look at cosecant of x minus 1 plus 1, this looks an awfully lot like a minus b, a plus b. That factors quite nicely into cosecant squared minus 1 squared, or just 1. All right, we're going to leave the right side alone. We're going to try to make the left side look like the right side. All right, cosecant squared of x minus 1. What does that turn into? That turns into cotangent squared. I'm getting this from the formula worksheet. All right, and so we're out of things to do unless we turn cotangent into sines and cosines. So let's see what we got here. Sine squared x times cotangent is cosine squared over sine squared. Those go away. We're left with cosine squared. What does cosine squared equal? It equals 1 minus sine squared. And we have just made our left side equal our right side, which is the goal of what we want to do. So we are done. Here we go, last one to try. Let's verify. And so we'll use the same strategies. Which side is more complicated? The right side is. So let's clean this thing up. When in doubt, turn everything into sines and cosines. So cotangent is the same thing as cosine cubed alpha over sine cubed alpha. You know what? I missed something. We could do this, but it's going to be more complicated because there's a cotangent in both of them. Let's factor out. It's going to be faster. Cotangent cubed alpha, cosecant squared alpha minus 1. And luckily, cosecant squared alpha minus 1 is equal to cotangent squared alpha. Put them together. You got 5, which is what we wanted. And we have a solution. So there you go. There's worksheet 5.2.